Okay, so how do you construct the hypothesis or hypotheses if we're thinking about the plural, more than one? Now, what I would say is before you watch this video, make sure that you have watched the video on writing a research title, that you also know how to write the general background in an introduction and understood the rationale, and also watch the video which is on the testable question. The reason being that if you've gone through all of those, you'll have understood that the introduction is this funnel-based construction. And so everything else that we've gone through, the general background, the rationale, the testable question, brings us to this, which is the hypothesis. And so when we're thinking about the hypothesis, we have to think about it in two angles. First part is, I've got to design a hypothesis, which in itself is going to be testable. The second part is, how do I then write the hypothesis for the purposes of the introduction to a report? And we're going to try and cover both of those within this video. So let's think about, why do we have a hypothesis? Well, they're really there to provide context against which our testable question and therefore our overall structure for the study has been developed. Now, let me be clear, these only apply to quantitative research. You do not use a hypothesis of any form in a qualitative-based study. Okay, they are not hypothesis-driven. So only if we're dealing with quantitative-based research do we use these and do these apply. And what they are about is kind of giving evidence. And it's evidence in terms of relation to the background to the study and the outcomes of the study that you've devised. And one of the things I would say is that quite often we get very despondent when we do research, because we get to the end of it and we end up showing that that our hypothesis, that is our prediction, was false. Okay, we didn't find what we thought we were going to find. That is just as important as actually finding what you were hoping to find. Okay, so don't feel that when you are accepting or rejecting a hypothesis, which we'll talk about in later videos, that you've always got to find a positive result. We don't. So the first thing you've got to think about now is developing your hypothesis. And there are a number of kind of little tricks and things to think about here. And the first thing is, well, there are two basic logical ideas or logical approaches, what we call inductive and deductive. So an inductive hypothesis or inductive reasoning is the kind of the testable question. So this is kind of the connection between the question and the hypothesis. So an inductive question is one really which comes from the idea of specific observations, and it goes to the idea of generalization. So you can see here, this is an inductive example. So Anna is a female and plays rugby. Therefore, all females play rugby. So that's inductive reasoning. We've taken an observation, which is that Anna plays rugby and Anna is female, and therefore we're saying, well, actually, we can move to generalization. Therefore, because Anna is female and plays rugby, all females must play rugby. However, what we tend to work with in science, generally, not dismissing the inductive approach at all. In fact, inductive approaches have their place. But we tend to work using deductive reasoning. And this, again, is that kind of going back to that testable question. So from this, we move from generalization to specific observations. In other words, we flip it round. So when you think about kind of your introduction, and we've been referring in all the videos about moving from a broad to narrow funnel, this kind of inverted pyramid, it makes much more sense in that construction to think about it moving from generalizations, which are broad, to specific observations, which are narrow. Now, how do we do this, and what makes this different to kind of the inductive approach? Well, it's first thing is this. Look, you cannot directly test a theory, and you can't do that through deductive reasoning. You can't do it really through, well, you can do it through inductive reasoning, but you can't do it through deductive reasoning. But you can develop a hypothesis which is based upon the general theoretical principles. In other words, you have read the literature. The literature has driven your rationale, which creates the testable question. So can you see, you've moved from generalization, the broad overview, to develop your rationale. So in other words, you are going to test your question against the general principles. Does what we find match up with the general principles? Does it fit the gap? So fundamentally, you've got to get that rationale correct. So if you're unsure about the rationale, go back and watch the video on writing the rationale and setting the rationale. And then again, the whole notion of this is because you're moving from generalizations, the general ideas, to a specific observation, we've got to make sure that the literature is used to set that generalization. Remember, it's about the gap. So when you're building that testable question, which is discussed in a previous video, make sure that you really come at this, I think, from a deductive approach. Make sure that you've kind of gone from the broad aspects, you're finding the gap, what are you going to test? You're testing that gap in the research. So here, you can see the same kind of principles, but we flipped it round. So here, all females play rugby. There's the generalization. So Anna, who is female, will also play rugby. Can you see that we've gone from an inductive approach? Let's just go back. Here's inductive. Anna is female, so that's very specific and plays rugby. Therefore, the generalization is that all females play rugby. So it's flipping it round. Whereas here, we're starting broad. So you would start with the broad context, which is the gap in the research, which is, well, all females play rugby. So Anna, who is female, must also play rugby. So you've narrowed it down to your specific observation. So now we have to think about the particular types of hypotheses that we want. And there are really two major types. There are what we call directional and non-directional. And one of the things to think about with these very much relate to the statistics that you're going to use. So that's something to bear in mind here, that the statistical approach that you use is driven by the hypothesis that you state. So for example, if we've got a directional hypothesis, we have to use specific terms, and you can see the terms that we've kind of got listed here. So it might be that there's a positive effect or a negative effect, or something is less or more than, or greater or smaller or higher or shorter. So can you see that by definition, it implies a direction? I've written relationship, it doesn't have to be a relationship, it could be the change, it could be the difference. So in other words, you could state that, for example, doing high intensity interval training will produce a significant increase in VO2 max. We have stated that VO2 max will increase. So it's directional. But one of the things I would say here is you cannot state a directional hypothesis as a question. It's always a statement. And it's always expressing the effect of your independent variable on the dependent variable. So hit is our independent variable. VO2 max is dependent upon doing the hit. Therefore, the hypothesis is that high intensity interval training will have a significant, will significantly increase VO2 max. So it's the independent, which is the hit, increases the dependent variable, which is the VO2 max. However, we may not be sure, right? So even when we've done our reading and we've developed our hypothesis and our testable question, we may not be sure about the direction. So we're not sure whether it's going to, in that example, whether VO2 max is going to increase or whether it's going to decrease. So by definition, what we do is we ask that as a question. So you never write these as a statement. So in that example, it's does a period of HIIT training affect, or does a period, no, rephrase that, does a period of HIIT training cause a change in VO2 max? So we've said causing a change. We don't know whether the change is an increase or a decrease, but we've still got the fact that we've got our independent variable, which is hit, and we're saying that it's going to potentially cause a change on VO2 max, but we don't know whether it's going to be positive or negative. It's non-directional. So one of the things you have to think about is when you are running your statistical, writing your rationale, and therefore your testable question, you have to start to think about, do we have evidence that suggests what we think is going to happen? Do we think it's going to increase, therefore, or decrease, therefore it's directional, or actually is the evidence, the gap in the research not clear, and therefore we are not entirely sure which way we are going to go, which therefore means it's non-directional. And if it's non-directional, we always write that as a question. If it's directional, we always write that as a statement. And then the final thing here is the notion of null and research hypotheses. So the research hypothesis is in essence our is what we have seen on the previous example. So it's either directional or non-directional hypothesis. So it's the relationship between the independent and the dependent variables. Your null hypothesis is that there is no relationship or there is no effect between the independent or the dependent variables. You can actually get away with not stating it. It's kind of implied, but it's good practice, particularly I think if you're writing a large report like a major research project, to always state the null. So for example, if I've got a directional hypothesis, which is HIIT training will significantly increase VO2 max, my null hypothesis will be that HIIT training will either not increase, which is in other words the opposite, okay, or it might be that the null hypothesis will be that there is no change on VO2 max. Because if you kind of go for the negative, it's almost a research hypothesis in itself. So I'll state that again. Directional hypothesis is that HIIT will increase VO2 max. The null is that there is no effect on VO2 max. So it's not that it's a decrease, no effect. And then the final thing here is keep it simple, stupid. What do I mean by that? Well, basically, you've got to make sure that you've got hypotheses that fit the testable question. So, for example, let's imagine that you've got a study which is addressing HIIT training on cardiovascular responses to exercise. Okay, so HIIT on cardiovascular responses. Now, in that situation, in your testable question, you may have identified VO2 max. You may have identified, for example, cardiac output as being parts that you want to test. Each of those has to have a separate hypothesis, because VO2 max could increase, it's possible, but cardiac output didn't change or doesn't change. So what you have to do is you have to break down the testable question, your deductive reasoning, into separate hypotheses and deciding whether you think they are directional or non-directional. You cannot have a single hypothesis. So for example, you couldn't word a hypothesis which was HIIT training will increase VO2 max and cardiac output. The reason you can't have that is because what happens if VO2 max increases but cardiac output decreases? So you have to separate them out. You give each of the major variables its own testable hypothesis. So let's have a look at that very briefly in the worked example. So previously we have established the testable question, and remember this has come from the position of deductive reasoning, that we've moved from a kind of a generalization from the rationale into our specific observation. So now what we've driven is the hypothesis. And notice, because the word count in this example is quite limited, that the way the hypothesis has been worded, it is hypothesized there will be no difference in the minimum number of trials needed between sexes. So in other words, there will be no difference, no change. But there will be a difference in the reliability across trials for these two conditions. So what it's done is it's separated them out. We've got two stated hypotheses. Hypothesis 1, no difference in the minimum number of trials needed between sexes. So in other words, we're stating that there will be no change. And in the other one, that there will be a difference in reliability. But notice that they are which way the difference will go, particularly in the second one. Whereas in the first one, we're stating there will be no difference. In the second hypothesis, we're not stating the direction. So when you're putting your hypotheses together, remember the basic rules. Have you used deductive reasoning for your testable question? Are you stating whether you have got a directional or non-directional hypothesis? And then, is there a null or alternate hypothesis to go with that? Here, we haven't provided it because, again, you can imply that. But notice that we've got them separated out into in essence, two testable hypotheses.